Welcome back, everyone. Next, we have Churchill Resources Inc. It trades on the TSXV under the symbol CRI and is a newly listed explorer focused on high-grade nickel sulphide and diamond projects in Canada. Please welcome its CEO, Paul Sobie, and the IR, Alec Rollins. Nice to see you, gentlemen.
Thanks, Anna. Nice to see you, and welcome, everybody. Thanks for joining us.
All right, the floor is yours. Call me back when you're ready for questions.
Okay. Excellent. So yeah, as Anna said, we are an exploration company, and we are looking exclusively, I would add, for nickel sulphides in Canada, which is home to some of the world's great mines. And, we're trying to find the next one, basically. So, next slide. There's our forward-looking statement. I make sort of some modestly forward-looking comments through the presentation, so please be advised. And this is what we're doing. We have two very, very good nickel projects in Canada. And of course, I think everybody knows that nickel has become very, very topical. There is a need for it, both for battery metals, but as well, it's always been one of the building blocks of modern society with in electronics and stainless steel and things like that. And, in the US, there's only one mine. It's called Eagle. It's in Michigan. And it's close to shutting down. It probably has 3 or 4 years left. And, there are no other projects that have been advanced into development. So, Canada being right next door, we are, your good friend and a good supplier of raw materials. And we are very, very well endowed in that we have 4 world-class mineral districts as opposed to single mines. And they all produce this clean Class 1 nickel, which is what we want for stainless steel and for the electronics and battery industries. And what we're trying to do is find the next great district. So there's 4 great districts in Canada. We want to find the 5th. And to do that, we have 2 really, really compelling projects. These were picked after quite a long time reviewing all sorts of opportunities. They're both in Newfoundland and Labrador, which is Canada's easternmost province, and it's home to nickel and iron ore mines. And it's part of North America. It'll be easy to to become part of the whole supply chain in North America. And we're really excited by results to date. So Taylor Brook is the project I'll be talking about today. It's the one we've done the most work on, and you can see that we've had an intersection there of 2.8% nickel. So just to put that into context, anything over 1% nickel is regarded as high grade, and 2.8% nickel is regarded as, fabulous. So if we can find a whole bunch of that, we're away to the races. Florence Lake, our other project, is in Labrador, so a little bit further north, but again, extremely good grades have been found in the past. And, we are working on a district scale project there as well. The team, it's myself and a bunch of very, very experienced geologists and capital markets people. We're applying a very, very systematic approach to our exploration. We're using all the latest science and all the best consultants and contractors in the world. And, we are big believers. We are all investors, big investors in this company. And, we are excited about what we're doing. And, that last point there is that we are actually one of the few active explorers right now. So we are generating new data and new news that we'll be bringing to the market. Oh, sorry, So our capital markets profile looks like this: 140 million odd shares outstanding. We're a penny stock. We're trading at 9 cents, I believe, Canadian. So, we're only worth $12 million. In Canadian dollar terms. There's nowhere to go but up, really. I mean, if we can discover something and show that it has value in the hundreds of millions or billions of dollars, then you can see where our market cap will go. The share breakdown is shown here. Management, as I mentioned, we are all vested. We own a big portion of this company. And I mentioned we had a very, very systematic approach. So we only came into being as a public company 2.5 years ago. And since that time, we've been very, very active. It is our policy to spend every dollar we can. Our G&A is very, very modest. Everything else goes into the projects. And, we've managed to raise $11.3 million to date. We spend virtually 90% of that on the projects. And, you can see sort of the timeline of what we've been doing. Right here is what's most important. Through all of these various steps and all of the money we've spent over the last 2 years, we are now at a very, very compelling stage where we're drilling targets that we believe are going to lead us to, to new discoveries and perhaps multiple discoveries. The projects, as I mentioned, they're in Newfoundland and Labrador. So this is Canada's very, very easternmost province. It's on the Atlantic Ocean. This makes it very, very accessible in terms of shipping. It is, as I mentioned, home to world-class nickel and iron ore mines. So this is the biggest iron ore mining district in North America. The Voisey's Bay nickel mine is a world-class mine that was discovered back in the early 90s. It was at that time owned by a fellow you might know named Robert Friedland and his company, and it was sold to what was then Inco for $4.5 billion US, and this was back in 1997, I believe. So the mine's been in production since 1998. It still continues to this day, and it has reserves and resources that will go for decades further. So an absolutely fabulous project. It's just to the north of our Florence Lake project, and down at Taylor Brook on the island of Newfoundland, we are in a completely or a very, very similar analogous setting geologically. And that's what's got us initially so excited about the project. But infrastructure is fabulous. And that little inset map that you can see there, you can see all of Canada's great nickel mines. And then down in the States, there's the Eagle mine that I mentioned and the Tamarack prospect nearby in Minnesota. So what do we look for when we're trying to find a very, very good nickel project or a district in our setting? Well, in our case, and there's a bunch of criteria that have to be present, that absolutely have to be present. And this was our checklist as we were going through deciding on the projects that would become the backbone of this company. Taylor Brook was our first project. Florence Lake came along a little bit later, but both tick all the boxes. And this is very, very important. They're at the right setting in terms of where they are on the continent. There are major crustal sutures present, which means that fluids can work their way up from the Earth's core. They're large. We wanted something large. We wanted multi-deposit potential, and both of these projects have that. And these other things, which gets more and more technical, I would add. These are very, very important steps for the geology and the mineral deposits to form, and we have all of those as well. So, they tick all the boxes, and they became the backbone of Churchill Resources. I mentioned being on the edge of the craton. This is little schematic diagram, kind of shows it to you. And, what's happening here is what's called subduction. It's continental drift, but it's creating an enormous amount of volcanism at this rifted margin. And as you can see, the world's great nickel mines and nickel camps are in this location, as are our projects. I put these little numbers beside Florence Lake and Taylor Brook up above. So Taylor Brook, I say 3 and 4, and that goes into the little schematic diagram on the right there, where, we are down into the magmatic plumbing system, if you will, of how these things form. It all starts down in a major heat source, number 1 there. So with Taylor Brook, we're looking for something that will be a channel or a conduit. And at Florence Lake, it's actually nickel-bearing lavas that extrude. So 2 different deposit models, but these are the 2 great nickel source deposits types in the world. We mentioned that we're looking exclusively for high grade. And the reason is really very, very simple, is that the world's great mines and great deposits are all high grade. And, these deposits, they're slam dunks. From the second they're discovered, they look like they will be mines. They encourage more work. They become very, very large. And, they have all been in production for decades and in some cases, more than 100 years at Sudbury. So, our decision to look for this type of deposit and this scale of deposit was very, very well thought out. I mean, we really wanted to make sure that we were on this tail of new districts that could join the Raglans and the Thompsons and the Voisey's Bays of North America's nickel production. The Taylor Brook, the best analogy is one of the deposits at Voisey's Bay. That has a reserve of 6 million tons of, as you can see, 2.1% nickel and a bunch of copper and cobalt. The resources below those reserves more than triple that number. So it's up around 20 million tons. Florence Lake is analogous to Raglan. So Raglan is another volcanic nickel deposit or nickel camp. And their reserves are 10 million tons. The total resources about 25 million tons. And that's what it started with back in the late 90s. So these deposits, these mines, I should say, they mine out certain deposits, but they keep finding more ore. They keep replacing what they exploit. And that's the reason they're so long-lived. And that's the reason we want to find a couple of these. Voisey's Bay, again, this is our best analogy. And as you can see, there's a bunch of different deposits. Reed Brook on the left, Discovery Hill, which was the original discovery, the Ovoid deposit, which is the open pit that's now almost mined out, and then some deeper mines, Eastern Deeps and Northeastern Deeps. Well, these collectively add up to about 150 million tons of high-grade nickel. So an extremely big mining complex. They have now gone underground on both Reed Brook and Eastern Deeps, and they're supplying the mill from underground. But it's still a small mine in terms of tonnage comparison. 6,000 tons a day is a relatively small mine, a very small footprint in terms of its mark on the land. And it produces as much nickel as some of the very, very, very large low-grade deposits. So you don't need large to produce the same amount of nickel.
I might just add that when you look at that, not all of that was known at the time that Inco bought the company. I mean, this is an iterative process as you go and you're discovering, and all of that is within about a 4-kilometer trend. It's all sitting within about a 4-kilometer trend and has been discovered. And the most recent discovery has been in the last couple of years of additional zones.
So the little diagram at the top there, and I hope you can see it, but there's a purple zone down beneath some colored zones, and they are discovering more and more and more ore at Reed Brook. So it is growing, and they're getting very, very high-grade results. And I don't know if you saw the news today, but Vale has announced $10 billion investment in their Canadian projects, including Voisey's Bay, over the next decade, and really, really talked about the great investment jurisdiction that is Canada. They were over at the Saudi conference as they were doing this, actually. So Taylor Brook, this is what we've been talking about in the press for quite a while now. This is our flagship project, and I'd just like to give you a little bit of an update and kind of just the history of how we got here. This is the discovery outcrop, and that is Dawn Evans-Lanswood, who is one of our consultants. She was at Voisey's Bay right from the beginning. She's a nickel expert and a structural geologist. And what's important about that outcrop is those dark bands that you see there in the rusty area. That is the high-grade nickel. And so you can see it's kind of a breccia. They're seeing stringers and shoots of it. That was all that was known about Taylor Brook when we got started 2.5 years ago. We've now shown that this breccia is huge at this area called Leyden. And, we're searching for its extension at depth now. That rock that you see in the foreground of the picture, that dark rock down at the bottom left, that's the host rock. That's really, really important. That's called a gabbronorite. And that's the rock in which the nickel is deposited. And I guess one of the biggest things we've done now is we've shown that this thing isn't a little dike. It's actually part of a massive system, both in this particular area, and we now have about 13 kilometers of it. And that is our district story. That's what's got us so excited. Those pictures you see, that's our guy sampling it last summer. It ran about 3% over 1.5 meters at that spot where you see Dawn. The logistics of this project are one of the things that are, it's just a huge, huge advantage. So we are in Western Newfoundland. Deer Lake is a major airport. You can fly there in 2.5 hours from Toronto, a direct flight. I'll be taking one on Monday, actually. And you're at our camp within an hour. You're on the Trans-Canada Highway briefly, and then our camp is a permanent camp. We actually share it with a fellow named Chris Verbitsky, who is the co-discoverer of Voisey's Bay. He's continues to explore. He's a shareholder of Churchill. He's exploring for gold in the same region. The camp is fabulous, though. It allows us to be extremely comfortable, extremely proficient. And, this area itself, it's a real mining jurisdiction in that there are mines around. We've got laboratories. We've got drill contractors. So everything's relatively easy. The one really important point I'd like to make is that power lines coming down from major hydroelectric projects in Labrador, they pass within a few kilometers of the project and about 10 kilometers away from the area that we are exploring most intensely. So the geology now, I mentioned you have to be out on the Craton margin, a rift and Craton margin. And I wish I could point to this for you, but the pink rock on the left where Taylor Brook is situated in that left diagram, that is the very edge of the Canadian Shield. And that's where we're located. Everything to the east of that or to the right of that in the island of Newfoundland is rifted on pieces of other continents. And so we are right on the very, very edge. And that map on the right, there you're seeing where the Leyden showing is, where that picture was taken. And it's immediately beside a great big green blob there called the Taylor Brook Gabbro Complex. Now, this is a rock that's quite young. It's only 430 million years old, whereas the country rocks are about 1.1 billion years old. And what we've been able to prove is that the mineralization and the rocks at Leyden are now exactly the same age as the south lobe of the Taylor Brook Gabbro. And in fact, it's all connected. It's all there at the edge of the continent. And you can see the suture down in that's that sort of tooth-like symbol. That's the very edge of the continent. So we're right where we want to be. And we have this big intrusion that's immediately beside our mineralization, and we now know it's all related. So this is the stew you want to see that's creating the plumbing that's likely to develop into a nickel deposit. So we acquired this property. We've been exploring it really, really aggressively, and the map on the left here, this is a VTEM survey. So we are looking for conductors with that survey. And what you see is a big swarm of conductors in the area of Leyden. And that was very, very important to us. That was showing us that there was metal in the rocks, and that we had to suss it out. Down in the south lobe of the Taylor Brook Gabbro as well, that really pink, vibrant rock. A lot of conductivity down there as well. And I guess, one of the things that's very, very exciting about what we're doing is that we're now, as I mentioned, able to show there's a relationship, both in terms of age, but in terms of the rocks themselves, that ties everything together. So this is our magnetic picture, a little bit more detailed. This is a survey we flew probably about a year after that previous one. And it was designed to really give us a better feel for the rocks, more detail, that sort of thing. And what you're seeing, and I've outlined it there with the squiggly line, is what we thought was our conduit. Our conduit is this magnetic area, this long linear feature that's heading back towards the Taylor Brook Gabbro South Lobe, the big purple feature there. And, we've been able to find nickel mineralization in many places along that trend. The perspective view on the right there maybe shows you a little bit better, but all of our soil sampling is those yellow columns. And the taller the column, the more nickel we got in it. And so we were seeing it all around the Leyden area, which was very, very good. But as well, we were seeing it back into the Taylor Brook Gabbro, where we've generated new drill targets that will, that we will get to as we finish the present program. We also flew what's called a mobile magnetic telluric survey. MMT is easier to say. It's just a hell of a lot easier to say. So this survey is looking, it's doing the same thing. We're trying to trace our magmatic conduit. And what's really exciting about this thing is that purple sort of fish-shaped feature on the left-hand diagram. It's actually definitively going now into the Taylor Brook Gabbro. So this is our plumbing system. It's about 13 kilometers long. We believe the Taylor Brook Gabbro is the heat source, is the pump that would have sent the mineralization and the lavas out into our conduit there. And just to put that all in perspective of how big that thing is that little inset diagram there that shows you the footprint of the Voisey's Bay deposits. So 150 million tons of ore bodies there would fit into our big purple feature there really, really easily. The area we're looking at is that one that I've got the little 1.2 kilometer area. That's the area where all that conductivity was. That's the area where the Leyden showing is, and that's the area where we've been really having some success in terms of putting together the plumbing picture and finding more nickel. A lot of that was done last year when we really explored the Leyden area. And that map on the left, it's very, very busy, I know, but each of those brown bullets, those are our high-grade intersections. And they're all sort of concentrated or focused down in the bottom, as you can see, along kind of a linear trend, the one I call the keel and the feeder dike, the brown and the blue one. Up above that pink purplish feature, that's the breccia zone. So that's where that picture of dawn was taken. And that mineralization up there, it's lower grade, it's more dilute because it is a breccia. Whereas down below, the high grade material, there we are getting into massive sulfides. And again, we can get up to 3-4% over a couple of meters. What we're looking for is those sorts of grades over 10 or 20 meters. And that's where the surveys have really come into the fore. So we announced back in October, I believe, that our CSAMT, so this is the ground version of that airborne survey I just showed you, was pointing to very, very compelling targets more at depth, below Leyden. And what we've done since then is really expanded on that picture. So those two sections on the right there, they are showing where Leyden is and where the high grade is, that red bar. But we are seeing very, very compelling targets within the same rock type down below from our initial survey. And that's really important because this deposit type, it needs a plumbing system. It needs a plumbing system where the magma is working its way up towards surface, and it runs into various areas where it will pool, where the nickel sulfides will pool out of the magma and result in deposits and hopefully ore bodies. But they are structurally controlled, so they happen in certain areas. And what's very, very pleasing with our larger survey we've flown now, or that we did on the ground, I'm sorry, is that section on the right. So what you're seeing there is kind of that hammer-shaped or axe-shaped sort of feature, the blue there with the orange clementines down in the bottom. That is very analogous to the one on the left, in that we are seeing a horizontal component to it and a vertical component. The vertical component should be the primary vent that is working its way up. And what's very, very, or what's been very, very pleasing is that we are finding the right rocks. That blue feature there is absolutely and definitively our gabbro-norite rock. In other words, the host rock to our nickel mineralization. And we're finding it in a lot of areas. So I'm showing that same section on the left. On the right is a bit of a plan map and just showing our progress to date. So we started out and we have drilled probably about 3,000 meters now. We are presently on hole 38. Hole 37 was just ended yesterday. In each case, we're going after the blue material and then down into the orange material, which is the areas that have the better chance of being sulphide pools. And we're very, very pleased with production. We're pleased with the rocks we're seeing. The model is working very well, I guess is the way to put it. The variety of targets here. So I've just shown the sections that what we're doing there. So line 14 west is the one up in the northwest corner there. There we're drilling 2 holes. Hole 37, as you can see, was going right down the vertical feature. Hole 40, which we'll drill a little bit later, is going after a shallow feature that's in the horizontal component of our plumbing. And each of these sections that you can see where we're drilling, it's a very similar sort of architecture. So this is giving us quite a bit of confidence that, it is all probably one system. It's all interrelated in some way, shape, or form. And what's very, very cool is that, from hole 35 down in the east up to hole 37 is about 1.2 kilometers. So we've now grown our prospect or our prospective area from that one little outcrop that we inherited 2.5 years ago to this incredibly prospective plumbing system that we're drilling presently. So as I mentioned, we're about 3,000 meters into the program. And that's it really, is that, we've got a lot of compelling targets there. We will be reporting on results probably in about a month's time. In the larger context, this 13-kilometer feature is now really, really exciting, in that we're showing the big picture is truly in play. And we've got targets along there that we've already shown our perspective. And we'll continue to, to develop more with exploration this spring and summer. The high grade and the very high tenor nickel sulfides that we've seen to date are very, very important, in that they're telling us that this system, our Taylor Brook system, is capable of producing very high grade ore bodies, which is what we want, and that's what Reed Brook is like. And there's a couple pictures of massive sulfides there down at the bottom. And, the area that we're working is spectacular. Infrastructure couldn't be better. Unit costs are cheap. If we get to the point where we're building a mine, we have power nearby and, ports nearby. So the whole thing can be done in a very, very cost-effective fashion. So that's the project. And as I mentioned, there's a lot of news coming, and watch this space. And just the company itself, why we're a good investment. Well, we've got 2 great projects. I didn't even talk about Florence Lake. It's not as far along as Taylor Brook is, but equally as compelling, equally as exciting. And, we'll be getting there this summer with a major program. So, 2 projects that both have compelling high grade already found. And, our work is definitely showing that, there's more to be found, and we're on the right track. Newfoundland and Labrador, as I mentioned, just a great jurisdiction and very, very encouraging of mining and exploration. Newfoundland and Labrador supplies an awful lot of the mining force for all of Canada. And they fly out and do rotations, and they would really, really love to have a mine in their backyard, so they wouldn't have to fly out, So it's a very, very encouraging local community as well in that context. And our team, we have a slide further on in the appendices. You can meet everybody, but it's a good team of people that have had success in the past, recognizing good projects, developing them, and selling them on at a later date. And that is certainly our intention with success for Churchill. So, Anna, I think I'll leave it there and invite questions.
Great presentation. Yes. We have a question. Roger asks, visually, can you explain what does the core of the holes drilled so far? What do they look like?
Well, it's that blue rock that I mentioned in the picture. And what we're seeing is, I keep trying to use my mouse to go back and forth. So you can see pictures of it here, Roger, that we're seeing that magmatic rock. We're seeing alteration in it. We're seeing, a lot of signs that it's been mineralized. And what's really cool is that this entire hole 35, from about 200 meters down to the end of hole at about 800 meters, was in that rock. So that is very, very significant. Past workers thought it was a tiny little dike. We can now show hundreds and hundreds of meters of this stuff. So, very, very encouraging.
Is there an upset limit on how deep targets can be for them to be economic?
There is. We're using sort of a rule of thumb at this point of 1,000 meters, in that, 1,000 meters is, it gets more difficult to explore. For one thing, you're drilling longer and longer holes. But, in our case, these are high-grade ore bodies, so they support underground mining. So there really is, you can go certainly much, much deeper. But from an exploration context, we want to find everything that's between surface and 1,000 meters at this time.
And a follow-up question is, even though you're drilling for high-grade deposits, is there a possibility for a low-grade deposit that may be open pitable instead?
I would say yes. The breccia mineralization that we're intersecting, it is low-grade. It's, 0.1, 0.2% nickel. Maybe enough of that exists in the right setting that, yes, that is a distinct possibility. These types of breccias are very, very common around high-grade massive sulphide. So, yeah, we'll see what we get, but we're certainly not dismissing that possibility.
Another question from the viewer, will there be a similar delay in obtaining new drill permits this year as there was last year? And would it have been better to have waited to drill deeper targets after doing the CSAMT and the MT over the whole trend first to see if there were shallower targets?
Great question. Thank you. Yeah. So actually, no, because our permit actually lasts for 2 years now. And, we got it in August, I believe. So we are good for 2 years. And we prepared we applied for and received permission for drill pads all the way along that big 13-kilometer structure. So we're in a very, very good position in terms of not having to have any real breaks other than just for data, sort of data compilation breaks to keep the ball rolling, to keep everything going and keep the momentum up.
Anthony Fitzgerald asks, how does your resource compare to other nickel projects, for example, FNI?
Well, we don't use the word resource because we're not there yet. We are looking to find a deposit, and then we will, develop that into a resource and hopefully a reserve. But essentially what we are looking for is, material that is 1% nickel or higher, and hopefully 2%, because that gets you up into the upper echelons of the great mines and the great mining camps in the world. I believe the other company was FNI.
Yes.
They have a similar target model. I think they're in northern Saskatchewan. And so they're probably looking for the same style of mineralization and the same tenor of mineralization that we are.
It might be worth just sort of distinguishing that the high-grade nickel sulfide that we're talking about is bulletproof with regard to the environment that you're in. So, the electric vehicle discussion, which is great, but if you find a high-grade nickel sulfide mine, it's irrelevant how quickly that market evolves or doesn't evolve. The demand for this product should be successfully be able to delineate it here at Taylor Brook will be in the radar screen of every senior mining company out there. We've spoken to most of them, and what we're demonstrating to them is that this is a district. It's not a single discrete play. This is a very large district that was heretofore unknown until we showed up. And so we are continuing to unravel this, and our knowledge base is growing. But now we know we're on a very large system. It is mineralized, and we are vectoring into where we think we're going to find high grade. And as soon as that happens, it'll be obvious.
Yeah, one thing I neglected to mention too is that every one of these holes is being surveyed by borehole EM methods. So we are able to see in a large circumference out around that hole. So each of them is a pilot hole, if you will, for seeing a big column of rock.
A few questions about the property. Vicki Oliver wants to know, has it been mined before? And if you can explain some of the history there.
You know, it's an area of Newfoundland and of Canada that has received very, very little exploration. So that's never been mined before, and we're the first ones to do this intensive of exploration on this area.
And Rob wants you to talk about any large discoveries or reserves around you.
Well, there aren't any. to put it bluntly. To the northeast of us is an area called Rambler, where there are copper, zinc, gold deposits. To the east of us is an area called Buckens, which was a very, very large historical base metal mining camp. But as mentioned, you know, this area of Newfoundland just hasn't received much exploration.
But you have to keep in mind that where we are on the rifted margin of the Canadian Shield, going back to a slide that was earlier showing where the location of all the big nickel mining districts in Canada are, they're all around the margin of the Canadian Shield, which is exactly where we are. And to the north of us is where Voisey's Bay was discovered. And to the north of that is where a mine owned by Glencore called Raglan is located. And Raglan, small mine, relatively speaking, but the richest and most profitable mine that Glencore operates. So we do have in the general neighborhood and beyond that rifted margin, there have been some other great nickel mines discovered.
Yeah, that's a good way of putting it. There's nothing local, but in a regional context, you know, we're right where we want to be.
Yeah.
And therein lies the opportunity, right? It wouldn't have existed if others had thought of that.
Sure. Opal asks for you to talk a little bit about the infrastructure at your properties. Does it need any money to be poured into it?
It really doesn't. You know, I had a slide there showing.
I mean, that's one of the things that we have here.
It's absolutely wonderful. What I failed to mention is that on the property itself is active logging operations. So we have a network of logging roads that go right to the area we drill, and everywhere throughout the property. All that's involved is some of them are overgrown. We have to open them up with a bulldozer, but it's really easy. So we have a network of roads all through that property that allows us to get anywhere.
So maybe I just want to add that, you know, given where we are in Newfoundland, which on the one of the most favorable mining jurisdictions in the world, this property is endowed with easy access by highway, the airport nearby, tidewater nearby, hydroelectric lines going right overhead, a skilled workforce in the neighborhood, all the services you could possibly require. So it's a dream from a point of view of a project. I want to contrast that with something that the people may recognize as the Ring of Fire project up in Northwest Ontario in Attawapiskat, which was sold to Wyloo about 2 years ago. And Wyloo, an Australian company, bought that project. It's 20 million tons, about 1.5% nickel sulphide. It is sitting under a swamp, really in the middle of nowhere, no infrastructure whatsoever. And they've got, you know, considerable issues with negotiating with the First Nations up in that area. None of those issues we have, but that's sold for $600 million. So and that's 20 million tons. So you're trying to put that in perspective of, you know, it's not a ton game here. This is, you know, we get onto something 2 or 3 million tons initially will be enough to say, confirm what's happening here in this huge system. And all that ground becomes very prospective very quickly as a result of that. So, you know, not so many tons can add up to big value.
We have two questions about Taylor Brook from Diane and Joe. First of all, what makes Taylor Brook deposit different from other Canadian nickel mines? And 2.8% grade, how much higher of a price does this command?
Yeah, so to answer the first question, Taylor Brook is, you know, it's not a mine yet, it's not a deposit yet, but it's exactly the same as Canada's great nickel mines in terms of the type of deposit that it is, how it forms, the grade is high, as mentioned. So it's very, very similar to Sudbury or Thompson or Voisey's Bay, three of the greatest nickel mining camps in the world. The second question about the grade is, you know, the grade is what we're searching for, because of course it makes it makes success that easy. If you hit something that's 2.8%, the whole world is going to sit up and take notice. It's entirely different than drilling 0.28%, which is you know, more common. So it puts a huge premium on Churchill if we can pull this off.
When you're talking about you fabricating and creating nickel sulfide and concentrates, you think about, you know, say 0.28 versus 2.8. You know, that's 10x difference, and Mother Nature's concentrated it for you. So you're starting with a much better product from the very beginning, and makes it much more valuable in terms of using it to, you know, whether you're making batteries or other alloys.
Joe asks, what depth have you reached, and talk a little bit about what's next?
Right. So I'll just bump ahead here to one of the slides on the drilling. Our deepest holes have been about 850 meters long, which, you know, it allows us to see about 1,000 meters, because the borehole EM probe goes down to the very, very end of the hole, and it can see another 100, 150, 200 meters beyond the hole, and as well in a circumference around it. So on each of these holes, we are doing borehole EM. That happens after the hole is finished. Obviously, the hole is logged and sampled based on what the geologist sees. But then we have this borehole EM information, and this will identify conductors. Conductors will be the ultimate target for future drill holes. As well, of course, what we're learning is the architecture and where certain pools of mineralization might be expected to be found based on this model of how these things form. And what's very, very pleasing is that our architecture seems to be conforming very nicely to the model. And therefore, this allows us to be predictive about other places to drill. So there'll be a little bit of a hiatus between this program and the next one, and then we'll be right back at it with a lot of new knowledge and a lot of new targets.
And last question is, how much cash is on hand, and what will the next raise look like?
We have over $1 million on hand, which is more than sufficient to get us through to the end of this project. The next raise will be, you know, similar in size or larger than our last one, and it would be designed to continue the work at Taylor Brook. As well, of course, we'd like to get Florence Lake financed and get it away to the races, because it's every bit as compelling as the story, you know, I've just told you on Taylor Brook.
Wonderful. Well, thank you, guys. Would you like to give our viewers some closing remarks?
Yeah, we'll let Al jump in.
I think that, well, if one's looking at the need for critical minerals, and nickel being one of them, and people are very focused on the electric vehicle, which is important. It's about 50 kilos of nickel in every battery. It's the biggest single component of any battery. But high-grade nickel sulfide does not require, doesn't require the electric vehicle industry to thrive. It's always going to be there. The reason is because nickel is the greatest density for keeping energy, and that's what gives cars the range. It's all about the range, and so you have to have a lot of nickel. So that's always going to be there. That's great. It's going to continue to grow. There's no doubt. Maybe not as quickly as a lot of people thought, but there's a lot of other uses for nickel. There's only a few nickel mines in the world. It is very rare. There's none in the U.S. There's one that will be out of business shortly. So we are in a bulletproof situation. All we need to do is identify where those high-grade pools are, and we will have, I think, every major miner in North America beating a path to our door.
Perfect. Well, let our viewers know where they can reach you in case they have more questions or are interested. How can they reach you?
Yeah, our contact details should be on the last slide. And both Alec and I are available anytime. Email, phone. Oh, sorry, went one too far. There you go. That's how you can reach us. And please, you can also give your details to the website, and you'll be kept up to date on absolutely everything we're doing.
Great presentation. Thank you so much, gentlemen. Please come back in the near future with some updates.
Definitely. Thanks, everyone. Thank you, Anna.
All right, everyone. We will be back at 2:55 Eastern with an update from Hilo. We'll be back.